Good morning, everyone, and thank you for coming along. And I presume there's a whole bunch of people online who we can't see, so welcome to everyone today. So I am Morgan Pratchett, and I have a problem. But I'm not here to admit that I'm an alcoholic, even though that's probably close to the truth. My problem is that, you know, when we sit in rooms like this and we think about what still needs to be done, the question is always sort of coming up where we all see it from very different perspectives. For some of us, you know, thinking about this, it's probably a glass half full sort of question, whereas others think the sort of glass is half empty. So in the context, what I'm talking about today is the glass represents the sum of knowledge that we need in order to make suitable management actions or design our suitable management strategies. And so for the managers, it's very clear that there is information on which to build on, right? But the question is like, have we got enough information, and are we done and dusted, and, you know, just get out of the way and let the management get on with it? So we actually looked at this very carefully in about 2017, and this is a review we did where at the end of his seminal review, Peter Moran listed 41 research questions. So a couple of years ago, I went through all those questions with a big group of other Cots researchers and assessed the extent to which we have actually answered those questions. So out of those 51 questions we have effectively, in my mind, answered about 60% of the questions, but there's still work to do, right? So the empty part of that glass is what we're talking about here, is the research opportunities. And so when I'm sort of up here, I'm always thinking about, well, what's next? And it's really up to you guys on the other side to tell us, what do you prefer to drink? What do you want me to put in that glass? Is it whiskey or is it just beer? So we need to make sure that we're servicing the sector. And so we continue to plug away and do some of this research, but you know, at times it sort of like seems, well, why are you doing that? So there are definitely questions where we have the answers, right? The glass is pretty much full. So an example of that is, what sort of coral do crown-of-thorns prefer to eat? And this is just one example of many, many studies I could put up. This was actually published just last year, and you'll wonder, well, why are we still sort of like beating this dead horse? Like, why are you still so interested in feeding preferences? Well, it all comes down to the context, right? So yes, we know the answer to that question reasonably well, and if you look at that graph, essentially they're ratios of how much they eat that coral to how much it's available. And the only one that really gets above the zero line, and I know there's a lot of variance, and we all know that crown-of-thorns eat a lot of different things, but it always keeps coming up that Acropora is very much the preferred coral. But the reason we're doing this is that when you take this glass and you put it into a bigger glass, then suddenly there's space for a lot more research. And it's also context dependent. So yes, we know what what crown-of-thorns prefer to eat, but then there's further questions. So why do they preferentially consume Acropora? How does the coral bleaching and the entire changing landscape of coral reefs impact on the feeding preferences and the behaviour of crown-of-thorns? That's a really critical question in my mind, because it's an ever-changing landscape, and we need to keep doing this research to really understand how things are going to be in the future. And also, the really key one, which I'm going to touch on today, is given that they prefer to feed on Acropora, what happens when there's no Acropora? How does the biology and especially the population dynamics get influenced by the amount of Acropora that's on a reef? So there's two things I'm going to talk to you about. One is the work we've been doing on movement, which was considered to be very important in understanding fine-scale management approaches under NESP. And we tackled this in a couple of different ways. We measured how fast crown-of-thorns could conceivably move in a tank, and then we also went out in the field and actually did all sorts of different experiments, including attaching acoustic tags to crown-of-thorns, and look at how they actually move around in the reef landscape. So this is somewhat old data, but you've probably heard of this before. The take-home message from this was just we put different substrates in the tank, and you can get there the movement rates of crown-of-thorns when they're moving as fast as they possibly can across those different substrates. Now, the reason that's important is, how do they redistribute themselves within and among reefs? Well, based on this information, we can then look at a crown of thorns and say, well, if it was to continuously move in a straight line between two reefs, how long is it going to take? So for those of you who know the area, if you think about Lizard Island to north direction, if you're a small crown of thorns, it's going to take you about 3 weeks. If you're a slightly bigger crown of thorns, because movement is very much size dependent, it's going to take you less time, but it's still in the order of weeks. And if you're going to get all the way down from Lizard Island to Endeavour Reef, it's going to take you half a year of continuous, constant movement. So you can see that, well, you know, they probably don't do it, but it's still interesting to know, well, you know, how much do they move? What is their actual energy budget? And so with that other work in the field, we've actually come to find that crown of thorns actually don't move very much. So on this axis, we've got the time steps along the bottom there in hours. So we're going out and we're continuously finding the same crown of thorns and seeing how far it's moved since the last time step. And for the majority, the far majority of them, they moved less than 10 metres over the space of a week. And so it was intriguing to try and understand, well, why? What are they doing? Where are they going? And we sort of had this notion that they must be homing. They must have really high fidelity to one specific location. So we took it a step further and we actually chose crown of thorns and set up time-lapse cameras over the top of them. And we did. We found that the crown of thorns come back to exactly the same sheltering hole in between feeding bouts. But they don't always do it. So what's the driver? And here's the answer. Acropora cover along the horizontal axis. As long as acropora cover is above around 20 to 30%, they home. But once acropora cover gets below that, then they start moving around looking for a better reef patch where there is acropora. So there's this real bimodal sort of behavioural pattern. So when there's low acropora, they're moving up and down the reef. When they find a good patch, they just stay there. And so they literally are hiding under these complex corals, coming out to feed, moving less than 10 metres and then going straight back and hiding in exactly the same place they were before. But this brings me to my next issue. Then if they're doing that and they're all doing this in slightly different times and things, well, you know, how easy is it to actually find these animals? And so another really important question is, how detectable are they? So we are all confronted with image after image of a crown of thorns sitting out in the open, and we just assume that they're the easiest things to find. And when you look at an image like that, you go, yeah, I can easily see how many crown of thorns there are. But in reality, there's probably just as many hiding down in the reef matrix. And, you know, these are the ones that are harder to see. And some of the control teams showed a very effective video yesterday where, you know, in order to inject them, they've got to get right under these acropora corals. They're not always just sitting out in the open. And so in order to measure detectability, there's a number of different ways you can do it. This paper that we worked on with a lot of people in this room, and collaboration between AIMS, Gabroompa and the university, tried to do a mark recapture exercise, and we looked at the detectability. And in this particular study, we showed that the average detectability is around 80%. But it's very much size dependent. And if you look at the far left side of that curve, it's the problem is that when they're really small, they're all virtually undetectable. You're only finding probably 20% of them. Even if you're going to the efforts that Eric's going to and carefully looking along an entire transect, I would maintain that there's probably a very large proportion which you just cannot find. That's not to say it's not useful work. It's important to get a proxy of the abundance, but we do always need to be conscious that, you know, it's not necessarily the true accurate measure of how many are there. So another way to look at this, and the approach we've taken, is to take advantage of the fact that they are still, you know, even in high densities, generally more active at night. So the little graph with all the squiggly lines is time throughout the day, where the dark patches are the nighttime hours, and the relative movement of those starfish during that time. And you can see there's two real peaks there. One is first thing in the morning, just before it's getting light, and the other is sort of just after it gets dark. So this comes back to that homing study again. So they start getting sort of a little bit worked up in the afternoon, and then as soon as it gets dark, they go out, they tend to start feeding, and then just before it gets light again, they race back home. Now, they're not all doing that, but that's the main pattern we're finding. So we then go out and say, on a given transect, how many did you see at night? How many did you see in the day? As just a ratio there. And this is very preliminary data. It's just, these are a relatively small number of transects, but you can understand it's quite logistically challenging to do some of this work. But the really key one I want to point out are these ones down the end here. So when you're in areas with very high coral cover, so on this horizontal axis here we've got coral cover, and here's the proportion of those starfish we found during the day compared to how many we saw at night. It's still not a perfect measure. There's still probably heaps that we don't see even at night. But you can see that at some high levels of coral cover, we're getting fairly low levels of detectability. So the issue is you go into environments like this where we know that there's probably lots of acropora, they're in that homing stage, and the system's just so complex you can't see what's down underneath and in amongst those table corals. So we have to recognise in certain habitats our detectability is probably very, very low. Now, it's even further compounded when we take certain survey methods, right? When you're flying over the top of that reef on a manta-tow board, it's even harder to sort of work out how many crown-of-thorns there are, because you really do only see either the feeding scars or the few that are really out in the open. So we've taken that and said, okay, it's really important that we scale up survey methods. It's really important that we do cover large areas, but we need the divers to be autonomous. They need to be able to stop and search for these crown-of-thorns. So the approach we've taken, and it might just sound like we're all just having fun out there, is we actually go out on these underwater scooters. And so we essentially do the manta-tow, we find the feeding scars, we stop and we actually look for the crown-of-thorns. And from that we can then get a different measure of detectability. How often, when we're sure it's a feeding scar, do we actually find the crown-of-thorns? And so this has managed to give us a lot more data about detectability, because it's not like swimming the same areas day and night, but there's lots of arguments about the extent to which it's a good or a bad measure of detectability, but it's another measure of detectability. So this is the data from this work. And what we're showing here along the axis here is the density estimated based on the total number of starfish plus the total number of scars. And then we look at our measure of detectability on the vertical axis here as the proportion of times where we find the starfish versus the proportion of times where there's clearly a scar. We're absolutely adamant that it's crown-of-thorns, but we can't find the animal. And the key thing here is that at these very low densities, our detectability is very, very poor. So we know they're there, but we can't find the animal. They're really cryptic in these low densities. And this is really critical when we talk about the thresholds that people keep putting up, whether we're working with the 3 animals per hectare or the 5 animals per hectare. Knowing exactly where we are within that space is going to be very, very challenging. We need to recognise that these measures of detectability will have a massive influence on the true density estimates we're going to get in these areas. And it is critical that we get reasonably robust measures of abundance if we're going to continually talk about these low thresholds. But it's even worse than that, because even for the ones that we do find, the number of animals which are out in the open is always very low, and it doesn't matter what size class we're talking about. So these bars, the different colour bars, are the different size classes, and on this graph we're looking at the proportion of individuals in different levels of exposure. So 0 means if you swim over the top you will not see the starfish. More than 75 means it's right out in the open and you could easily spot it. We started doing this with a group that were interested in the autonomous vehicles and trying to understand how many of the starfish they would actually see with that image recognition. You can see it's low. 80% of the starfish on average are hidden every time you do this during the day. So it is going to be quite challenging to change this and do it with, whether it's the glider or any of the other robots, because it's still only going to be a fairly rough proxy of the numbers out there. So it's not all doom and gloom, and I'm not as pessimistic as you might think, okay? But we do need to emphasise that effective management needs to be based on rigorous and robust scientific information. We all want to work together to make sure we have the best possible information. So in terms of this talk, we definitely need more information on detectability to align the surveillance data with those thresholds we talk about. And remember, there's still a lot of opportunities out there that we need to consider. What are the primary opportunities? Like, you know, as a group, do we want to fill this glass with beer or champagne? And that's the decision that we've got. We can't all have full glasses all the time. Thank you very much.